Hey guys, welcome to another lesson in the Science 10 chemistry unit. Today we are going to talk about ion formation. So we've talked about elements on the periodic table being in standalone, so meaning we've talked about their protons, electrons, neutrons, atomic number. Now we're going to talk about the idea of them coming together. So under some circumstances, the atoms of most elements will either gain or lose one or more of their outermost electrons. And this is the process of gaining or losing electrons is called ionization. So ionization results in the formation of an ion, and an ion is an electrically charged atom or group of atoms. So meaning when you look in your periodic table, you look up in the little top right-hand corner there of the periodic table that comes with your textbook, you see those charges. Well, that's what we're talking about there. Now when we have an actual charge, we're dealing with an ion formation of that element. When you have no charges, you're dealing with the atom form of that element. Now, ionization results in metals and nonmetals forming compounds. So we're going to talk about different going to have different ideas of when nonmetal and nonmetal come together and when certain compounds form with this other compound. But anyways, for right now, the idea of a metal and a nonmetal coming together is called an ionic compound. Now you have with ion formation, you have cations, and cations are positively charged ions. And these form when metal atoms lose electrons. And the lost electron usually moves to another atom. And so the question I have there, electrons have what kind of charge? Well, we know the electrons have a negative charge. So when the electron leaves the atom, the ion that remains is positively charged because it now has more protons than it has electrons. So to give you an example, or a cation example, the periodic table shows that sodium has 11 protons and therefore has 11 electrons. And that's what we talked about again there. You see the sodium atom is the key point here. Oops, sorry, that just hit you back. I'm noticing that my pen's not working. So anyways, the sodium atom right here has 11 protons and therefore also has 11 electrons. A sodium ion forms when the sodium atom loses one electron. Now the positive charge in the sodium becomes 1 greater than the negative charge, therefore giving the sodium ion a positive charge. An ion's charge is sometimes shown as a superscript after the atomic symbol, and in this case the sodium would be written as Na plus, or sometimes Na1 plus, Na plus 1. So we can see here within this example, we have the sodium atom by itself. So if you're looking at my mouse right here, so this is a sodium atom. Okay, usually not. Atoms themselves aren't always in a stable format. That's why there's the charges shown on the side or within your periodic table, because that's when they have their charges and they're losing or gaining electrons, they're in a more stable format. And now we can see an an energy liberates an electron. So I mean, we have this little electron right here, it's leaving. So that's why we have a sodium 1 plus charge. Now what I want you guys to do here, I just have a little example. I want you to write the cations of the following atoms. So lithium, for example, lithium losing 1 electron. Beryllium losing 2 electrons. Calcium losing 2 electrons. Strontium losing 2. Iron losing 3. And lead losing 4. Now I'm not going to show you this I'm not going to write the answers in there right now. If you want the answers, you can come see me and we'll discuss it in class. But because this example here is showing we're dealing with cations and we're talking about losing electrons, all these examples here should have a positive charge. And they have the positive charge of how many electrons they're losing. So example, calcium there is going to have a +2 charge. So it should probably be, and I'll give you this one, Ca2+. Now the next part when we're going into ion formation is the anions. And these are negatively charged ions. And these form when nonmetals gain electrons. So cations, positive, usually are metals losing electrons, and anions now are negative and they form when nonmetals gain electrons. So to give you an example of an anion, we have oxygen. And an oxygen atom gains 2 electrons. So meaning it's going to have a 2- charge. So the periodic table shows us that the oxygen atom has 8 protons and therefore it has 8 electrons. Again, we're talking about the atom. But by gaining 2 electrons, the oxygen atom becomes a negatively charged ion called an oxide ion and can be written as O2 minus. Now here's a really important part when we start writing out compounds, especially ionic compounds. The name of the element's anion is written by using the first part of the element's name and changing the last part to "ide." So that's why we said in the above bullet there, it's oxide, not oxygen ion. It's the oxide ion. And so last little bullet there, the nitrogen anion, N3 for example, is called nitride. And just give you a visual picture of that, we can see where we have Cl, for example, which is chlorine. Okay, it has 7 electrons in its outermost shell, and we said before that you want to have 8 in the outermost shell. So we have energy and a free electron that's floating out in the environment here somewhere, and it gains that electron. Now it has 8. So not super stable right here right now, to a lot more stable right here. So here's another part where I want you to write out the anions. So again, we have nitrogen gaining 3 electrons, sulfur gaining 3, fluorine gaining 1, bromine gaining 1, and selenium gaining 2. So again, I'm not going to write those out because we can talk about that in class, but you should have, because we are gaining electrons, you should have a negative charge because electrons are negative. So example, fluorine would be F1 minus. Now, most ion formation takes place when metals and nonmetals form ionic compounds. Now, what kind of atoms form cations by losing electrons? And that's a question I want to pose to you. So what kind of atoms form cations by losing electrons? So you should be thinking that we have, if we're losing an electron, we're dealing with a metal that has a positive charge. Now, why do metals tend to lose electrons and nonmetals tend to gain them? Well, atoms gain or lose electrons so they can have the same number of electrons as their nearest noble gas. And this makes them more stable, or it makes them less reactive. So we have helium, neon, krypton, radon, xenon. So all those in group 18 on the far right hand of the periodic table, everything in the periodic table wants to be like those because they have their valence energy shells full, and that means they are very, very stable. So for example, the sodium ion is less reactive than a sodium atom because that sodium atom has that 1 extra electron there. So when placed in water, sodium reacts vigorously, whereas table salt is an ion and it dissolves quietly in water because it has given up that extra electron. And that extra electron actually went with chlorine, which wanted an extra electron. So it becomes quite stable. Now the octet rule. So another way to understand the patterns by which atoms gain or lose electrons is to look at their energy levels. And all noble gases have their energy levels filled, as I just said. Atoms tend to gain or lose electrons so that they will end up with completely filled energy levels. So the octet rule, or the rule of 8, states that atoms bond in such a way as to have 8 electrons in their valence energy levels. And this is just another way to say that atoms tend to be stable with full outer energy levels. And sometimes they actually even have to share electrons so they each can have 8. And especially, we'll get into this a little bit, when you get into Chem 20, you're really going to start drawing out the molecular structure of some compounds, and you'll see how the sharing really goes on. But for example, right now, if we talk about chlorine, chlorine is just below fluorine in group 17, and all atoms in this family have 7 valence electrons. By the octet rule, fluorine will have an octet of electrons, or 8 electrons in its valence energy level, if it gains an electron to form the F1 minus ion. So that means it has its 1 minus, that means it has 1 extra electron. So this means that the chlorine atom will also gain 1 electron, forming the Cl minus. Because they have 7, they want to have 8, so they're minus 1, meaning they have 1 extra electron because electrons are negative. Now the exceptions to this rule are hydrogen, lithium, beryllium. They each only need 2 electrons in their valence energy levels because their nearest noble gas, helium, only has 2. Everything else wants to have 8. These 3 just want to have 2. Now transition metals. So these are the metals from groups 3 to 12, and all metals tend to lose electrons to become more stable, but it is difficult for atoms to lose more than about 3 electrons. And this is because every time an electron is lost, the remaining electrons are held more tightly by the core of the nucleus there. So it doesn't want to let everything go, because if it just lets everything go, I mean, it'll break down. The element itself would break right down. So it wants to keep them there. So each time one's gone, it's going to hold on a little tighter. So if we use the example here, gold, which is Au3+, it can lose up to 3 electrons. Now, if you consult the periodic table for the charge on these elements, the first charge that's given is the most common. And what I'm talking about there, if you look in your periodic table on page 30, some of the elements, for example, like lead even, you have a little 2+, and then you have a 4+ there in the top right-hand corner of the box for lead. And that means the +2, because it's over the +4, is usually the most common form of that ion. And that's all we got for today. So I hope you learned a little bit about ion formation. Next, we're going to start getting into actually naming the ionic compounds and talking about molecular compounds, which is two nonmetals together.